Okay. And then there is a law called polygon law of vector addition. Vector addition. Now, this law is applicable when you have more than two vectors, and it's pretty simple to understand. Let us say we have a vector like this. Let's say there is a vector A, and then there is a vector B. We will continue to draw these vectors one after the another using head and tail. So I can possibly draw C and then draw D. So we can say that this point is D. And we can call them as, let's say, vector D. So what is the final resultant? Let's say these are the four vectors we want to add. So we want vector A plus vector B plus vector C plus vector D. So what will be my resultant vector? I will again use the same methodology. I will use the tail of the beginning and head of the final. So how would I join them? I would join them like this. So this will be my resultant vector R. So I would say that this is my resultant vector R. Okay. I would quickly brief you about certain properties of vector addition. So I will say some properties of vector addition. So what do we get? Of course, we can say they follow commutative law. Commutative law. So what is commutative law? Vector A plus vector B is vector B plus vector A, right? So they follow commutative law. And then what is the, then they also follow associative law. Associative law. And what is this law? A plus bracket B plus C is equal to A plus B bracket close plus C. Simple. So both these laws are actually followed. They follow associative law of vector addition as well as commutative law of vector addition. Let us just take a small example to illustrate what we all have studied. Let's take an example. A car is moving round a circular track with a constant speed v of 20 meter per second. Okay. Let's write as shown in figure. I will draw the figure. At different times, the car is at A, B and C respectively. Okay. Find the velocity change A from A to C. This was A, and another is B from A to B. Let us just draw the figure and try to understand this problem. I'm drawing the figure. I'm drawing a circular track. And then I'm drawing the and writing point A, B, C, D. Now I would mark the vector direction. Let's say this is V, this is V, and from C, this direction is V. Now let us discuss for A. We have been asked in A, from A to C, what is the change in velocity? So we have been asked a change that is delta V from between A and C. So what shall we write this? We will write it as VC vector minus VA. This is the change that we would like to understand. So as we told that, how do we visualize this? Now VA is actually this 20. Okay. And we have to add the negative vector VA. In this was my VC. My VC is, let us just again do the slight correction. I want VC. VC is I want VC vector as VC is this. And if I want VA was like this was my VA. So what is my negative VA? Negative VA is like this, negative VA. Now what is my VC minus VA? As I told you earlier, it is VC plus minus VA. Now if I see both, the direction of the two vector is same. So my if I take this as a VA as positive x direction, so obviously the vector at point C having negative direction. So we would say that the resultant vector is negative 20 plus negative 20. So this is negative 40 meter per second. Negative sign shows negative x direction. Okay. So we can say that there is a change in velocity of 40 meter per second in the negative direction. Okay. Or we can say in the direction of VC. Okay. So let's now think for the solution of B. In B, what we have been asked? We have been asked change from A to B. From A to B. So what is my, so we want change from A to B. That means we are interested in delta V. A to B, we can write AB. So this is actually VA. minus AB would be writing as VB minus VA. VB minus VA. Now let us see what is my VB. So VB is down. So what is my VB? VB is like this. So I would say VB is downward vector. And we want to join plus minus VA. So minus VA would be something like this, because VA having positive x direction. So this is your 20 and VB is also 20. So net is, this is your resultant vector. So we can say that let's say this is VB को कुछ representation दे सकते हैं, O A and then or OPQ. So this represents VB and this is representing as negative VA. So what is my final direction? We can say from vertical, this direction is like this. Okay. And what will be my OQ? So OQ is under root 20 square plus 20 square. So we can say that the resultant is having a magnitude of 20 root 2, that is OQ. Okay. Or we can say that is my resultant vector. So 20 root 2 is our answer. Also, if we want to find this theta, so we can say my tan theta is 20 upon 20, which is fundamentally 1. So theta would be 45 degree. So this way we have illustrated through a practical example how the two vectors are added or subtracted. Hope you have liked this discussion. We will meet in the next discussion soon. Thank you very much. Love you all.